Hello and welcome to my video on cloud computing. This is YASHASHWINI DIXIT and my registration number is 19 BCE 1239. First, let's dive in and see what is cloud. The cloud refers to servers that are accessed over the internet and the software and databases that run on those servers. Cloud servers are located in data centers all over the world. By using cloud computing, users and companies don't have to manage physical servers themselves or run software applications on their machines. This is a diagram depicting the cloud, which has servers containing applications and databases which are accessed via the internet by a user device. Next up, let's see what is cloud computing. As said by Steve Jobs, co founder, CEO, and chairman of Apple, I don't need a hard disk in my computer if I get to run the server faster. Carrying around these non connected computers is Byzantine by comparison. Cloud computing is the on demand availability of computer system resources, especially data storage, cloud storage, and computing power, without direct active management by the user. The term is generally used to describe data centers available to many users over the internet. Large clouds predominant today often have functions distributed over multiple locations from central servers. If the connection to the user is relatively close, it may be designated an edge server. This is a diagram for cloud computing, which has application platform infrastructures, which we'll see later. Benefits of cloud computing. Now, let's dive in and see what are the benefits of cloud computing. First up, its cost. Cloud computing eliminates the capital expense of buying hardware and software and setting up and running on site data centers. The rack of servers, the round the clock electricity for power and cooling, the IT experts for managing the infrastructures, it adds up fast. Next, we have global scale. The benefits of cloud computing services include the ability to scale elastically. In cloud speak, that means delivering the right amount of IT resources, for example, more or less computing power, storage, bandwidth, right when it is needed and from the right geographic location. Next, we have performance. The biggest cloud computing services run on a worldwide network of secure data centers, which are regularly upgraded to the latest generation of fast and efficient computing hardware. This offers several benefits over a single corporate data center, including reduced network latency for applications and greater economies for sale. Economies of sale. Next, we have security. Many cloud providers offer a broad set of policies, technologies, and control that strengthen your security posture overall, helping protect your data, apps, and infrastructures from potential threats. Next, we have speed. Most cloud computing services are provided self service and on demand, so even vast amount of computing resources can be provisioned in minutes, typically with just a few mouse clicks, giving businesses a lot of flexibility and taking the pressure off capacity planning. Next up, we have productivity. On-site data centers typically require a lot of racking and stacking, hardware setup, software patching, and other time-consuming IT management cores. Cloud computing removes the need for many of these tasks so it teams can so IT teams can spend times on achieving more important business goals. Reliability. Cloud computing makes data backup, disaster recovery, and business continuity easier and less expensive because data can be mirrored at multiple redundant sites on the cloud provider's network. Next, let's discuss brief history of cloud computing, as in how it came to existence and how it is going on in present. It wasn't until 1950s that mainframes were born, introducing the notion of shared centralized computing and storage resources in the 2000s. The delivery of computing services occurred over the internet, including servers, storage, databases, networking, software, analytics, and more. The cloud in 1950s. As we can see, the word cloud still refers to visible mass of condensed water, vapor floating in the atmosphere. The mainframe is born, introducing the concept of shared centralized computer resources. In 1969, the first networking prototype of ARPANET is launched, linking four geographical dispersed computers over what is now known as the Internet. Late 1970s, the term client server comes into use, defining the computer model where clients access data and applications from a central server over a local area network. In 2006, the CEO Eric Schmidt utters the term cloud at an industry event. 2008, the concept of private cloud emerges, viewed by enterprises as a more secure version of the public cloud. Browser based cloud enterprise applications like Google Apps are introduced, revolutionizing the market for productivity applications and untethering user from their desktop. That is 2009. In 2011, hybrid cloud emerges combining public and private cloud environments. Apple launches iCloud, allowing people to automatically and wirelessly store their content. Present cloud adaptation is accelerating but still struggles to distinguish itself from the plain old internet. Next up, we have types of cloud computing. Not all clouds are the same, and not one type of cloud computing is right for everyone. Several different models, types, and services have evolved to help offer the right solution for your needs. First, you need to determine the type of cloud deployment or cloud computing architecture that your cloud service will be implemented on. There are three different types to deploy cloud services: a public cloud, on a private cloud, or on a hybrid cloud. This is a diagram depicting the functionalities. Public cloud. Public cloud are owned and operated by a third party cloud services provider. Cloud service providers which deliver their computing resources like servers and storage over the internet. Microsoft Azure is an example of a public cloud. With the public cloud, all the hardware, software, and other supporting infrastructure is owned and managed by the cloud provider. You access these services and manage your account using a web browser. This is a photo of public cloud which has IBM, Amazon, VMware, Google. Next up, we have private cloud. A private cloud refers to cloud computing resources used exclusively by single business or organization. A private cloud can be physically located on the company's on-site data center. Some companies also pay third-party service providers to host their private cloud. A private cloud is one in which the service and infrastructure are maintained on a private cloud. Private network. This is a photo for private cloud. Hybrid cloud. Hybrid cloud is a composition of public cloud and a private environment, such as a private cloud or on premises resources that remain distinct entities but are bound together, offering the benefits of multiple deployment models. Hybrid clouds combine public and private clouds bound together by technology and allows data and applications to be shared between them. By allowing data and applications to move between private and public clouds, a hybrid cloud gives Here business greater flexibility, more deployment options and helps optimize your existing infrastructure, security and compliance. This is a photo for private and public cloud having and making hybrid cloud. Other types are community cloud. Community cloud shares infrastructure between several organizations from a specific community with common concerns, security, compliance, jurisdiction, etc. Whether managed internally or by a third party and either hosted internally or externally, the costs are spread over fewer users than a public cloud but more than a private cloud, or only some of the cost savings potential of cloud computing are realized. Next is distributed cloud. A cloud computing platform can be assembled from a distributed set of machines in different locations connected to a single network or hub service. It is possible to distinguish between two types of distributed clouds: public resource computing and volunteer cloud. Next is multi-cloud. Multi-cloud is the use of multiple cloud computing services in a single heterogeneous architecture to reduce reliance on single vendors, increase flexibility through choice, mitigate against disaster, etc. It differs from hybrid cloud in that it refers to multiple cloud services rather than multiple deployment models. Polycloud. Polycloud refers to the use of multiple public clouds for the purpose of leveraging specific services that each provider offers. Big data cloud. The issues of transferring large amount of data to the cloud as well as data security once the data is in the cloud initially hampered adoption of cloud for big data, but now that much data originates in the cloud and with the advent of bare metal servers, the cloud has become a solution for use cases including business analytics and geospatial analysis. HPC cloud. HPC cloud refer to the use of cloud computing services and infrastructure to execute high performance computing HPC applications. These applications consume considerable amount of computing power and memory and are traditionally executed on clusters of computer. Next up, we have types of cloud services. Most computing services fall into four broad categories: infrastructure as a service, IaaS, performance platform as a service, PaaS, serverless, and software as a service, SaaS. These are so often these are sometimes called the cloud computing stack because they build on top of one another. Knowing what they are and how they are different makes it easier to accomplish your business goals. This shows the stack. Infrastructure as a service, the most basic categories of cloud computing services. With IaaS, you rent IT infrastructure, servers, and virtual machines, VMs, storage networks, operating systems from a cloud provider on a pay as you go basis. This is a photo for IaaS. Next, platform as a service, PaaS. Platform as a service refers to cloud computing services that supply an on-demand environment for developing, testing, delivering, and managing software application. PaaS is designed to make it easier for developers to quickly create web or mobile apps without worrying about setting up or managing the underlying infrastructure of server, storage, network, and databases needed for development. Here is also a photo depicting PaaS. Software as a service, SaaS. Software as a service is a method of delivering software applications over the internet on demand and typically on subscription basis. With SaaS, cloud providers host and manage the software application and underlying infrastructure and handle any maintenance like software upgrades and security patching. Users connect to the application over the internet, usually with the web browser on their phone, tablet, or PC. A photo depicting software as a service. Now let's see common functionalities and companies using them. SaaS is used for enablement, marketplace, custom packaging, premium CDNs, DNS, built-in billing, cloud scripting, Verizon, Verizon, Cloud Blue is using SaaS. PAAS has management, app deployment, auto scaling and clustering, CI/CD automation, container orchestration, GitHub, GitLab, Kubernetes, Dockers, these use PAS. IaaS is used for optimization, containers, virtual machines, network, storage. OpenStack, SEP, OpenKVM, Virtuoso. These companies uses IaaS. Next up, let's see serverless computing. Overlapping with PAS, serverless computing focuses on building app functionalities without spending time continually managing the servers and infrastructure required to do so. The cloud providers handle the setup, capacity planning, and server management for you. Serverless architectures are highly scalable and event driven, only using resources when a specific function or trigger occurs. We also have MBAAS, Mobile Backend as a Service, and FAAS, Function as a Service. In the mobile backend as a service model, also known as backend as a service model, web app and mobile app developers are provided with a way to link their application to cloud storage and cloud computing services with application programming interfaces APIs exposed to their application and custom software development kits SDKs. Services include user management, push notifications, integration with social networking services, and more. Function as a Service FAAS is a service hosted remote procedure call that leverages serverless computing to enable the deployment of individual functions in the cloud that run in response to events. Next up, we have cloud architecture and cloud engineering. Cloud architecture, the system architecture of the software systems involved in the delivery of cloud computing, typically involves multiple cloud components communicating with each other over a loose coupling mechanism such as messaging queue. Cloud engineering is the application of engineering disciplines of cloud computing. It brings a systematic approach to the high level concerns of commercialization, standardization, and governance in conceiving, developing, operating, and maintaining computing systems. Next, let's see some uses of cloud computing. You are probably using cloud computing right now, even if you don't realize it. If you use an online service to send email, edit documents, watch movies or TV, listen to music, play games, or store pictures and other files, it is likely that cloud computing is making it all possible behind the scenes. The first cloud computing service as barely a decade ago, but already a variety of organizations, from tiny startups to global corporations, government agencies to non-profit, are embracing the technology for all sorts of reasons. Here are a few examples what is possible today with cloud computing from a cloud provider. Create cloud native applications. Quickly build, deploy, and scale applications, web, mobile, and API. Take advantage of cloud native technologies and approaches such as containers, Kubernetes, microservice architecture, API driven communication, and DevOps. Test and build applications, reduce application development cost and time by using cloud infrastructure that can easily be scaled up or down. Store, backup, and recover data, protect your data more cost efficiently and at massive scale by transferring your data over the internet to an offsite cloud storage system that is accessible from any location and any device. Analyze data, unify your data across teams, divisions, and locations in the cloud. Then use cloud services such as machine learning, artificial intelligence to uncover insights for more informed decisions. Stream audio and video. Connect with your audience anywhere, anytime, on any device with high definition video and audio with global distribution. Embedded intelligence. Use intelligent models to help engage customers and provide valuable insights from the data captured. Deliver software on demand. Also known as software as a service, SaaS, on demand software lets you offer the latest software versions and updates around to customers anytime they need, anywhere they are. Next up, let's see some limitations of cloud computing. Disadvantages of cloud computing. There are benefits from the cloud computing usage, but it is undeniable that this system also has some disadvantages. These risks of cloud computing you should know, such as risk of data confidentiality. There is always a risk that user data can be accessed by other people. So data and cloud protection must be good because if it won't be dangerous for data confidentiality. Depends on internet connection. The internet is the only way to cloud computing. When there is no internet connection in your place or internet part to the cloud provider is in trouble, automatically access to your cloud computing machine will be disconnected. Now this is where the biggest obstacle is happening in developing countries and remote areas that do not have good internet access, and the weakness of public cloud is where everyone accesses the same server and will increase the risk of attack and down the server. The level of security. Secrecy and security are among the most doubtful things in cloud computing. By using a cloud computing system means we are fully entrusted with the security and confidentiality of data to companies that provide cloud computing servers. When you experience a problem, you cannot sue the server for errors in the data. When you experience a problem, you cannot sue the server for errors in the data. Compliance, which refers to the risk of a level compliance deviation from the provider against the regulation applied by the user. Vulnerable in the event of an attack. There are a lot of arguments against cloud computing, one of which is computing because the cloud computing work system is online. Each component that is on cloud computing can be exposed to a wide range. This is a wide open opportunity for attacks on data or activities stored on the server. When an attack is carried out by hackers, the problem that occurs are data security and data privacy. Data mobility, which refers to the possibility of sharing data between cloud services, and how to retrieve data if one day the user makes a process of terminating cloud computing services. And there is local storage where the data can be used at any time as needed. Technical problem. Besides that, the use of cloud computing makes you unable to manage it yourself. When there is a problem, you must contact customer care who is not necessarily ready 24 by 7. This is a problem caused because for some support you may also have to pay more money. Low connection does not work well if the connection is slow. The quality of cloud computing service is one of the most important considerations before we decide to provide cloud computing server service providers. When the server is down or the performance is not good, we will be harmed because of poor server quality. Well, that's the advantages and disadvantages of using cloud computing services. Not only the use of cloud is all just good, but there is also a shortage of cloud. However, never be afraid to use what is called cloud computing. Next up, we will see the future of cloud computing. The demand of cloud computing is growing every year. According to analytical agency Gartner, the global market for public cloud services will reach $308.5 billion in 2021. This is $40 billion more than in 2020 and 90 billion more than in 2019. The CEO and managing directors of many companies like Hewlett Packard, Swift Type have predicted that in the next decade it is going to have huge impact on the businesses and is going to grow at a very fast pace. Also, everything may be based on cloud soon. Hence, cloud computing has a very good scope. Now, I'd like to conclude my video. Thank you for watching.